All right, guys, fun fact, I got sick, so this is not live, and my voice might be a little rough, but we're going to go with it. So this video is my top 12, really 13, but top 12 things that you should know how to do for the exam. These are questions that come up every year that I am sure you will see in one form or another, and so these would be the things that I would make sure that you know how to do no matter what. So we're going to go through these step by step. I will reference some former videos that you can look at for these, but this again is my big 12, really 13. So first one is dividing a directed line segment proportionally. So I want to divide AB in a ratio of 5 to 2, and so I know that that means that I have 7 parts. And let's look at where my points are. So negative 2, 5, and that's negative 3, 5, Mrs. G. There we go. And the other one is at 12, negative 2. So this is AB. And there's a couple different things I need to know here. First of all, I need to know where this segment starts. These are directed line segments, so they go in order. So that's AB, which means we start at A, right? And then I need to know how many parts. And this is, again, 7 parts. So I'm going to sort of sketch in here a right triangle. And then I'm going to use what I know that this needs to get divided up into 7 parts to find this point. So this bottom is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And so if I break that up into 7 parts, each part should be 2 wide. So I'm going to put a dash every 2 boxes because that will be the size of 1 part. So there's 1 part, 2 parts, 3 parts, 4 parts, 5, 6, 7 parts there. So now to divide this in a ratio of 5 to 2, I want 5 parts on one side, 2 parts on the other, and since it was segment AB, I'm going to start towards A. So right here would be the point where there's 5 on one side, 2 on the other. I'm going to follow that up onto my line, which you should be drawing with a straight edge, and so that point is the point 8, 0. Now you can also do this algebraically. Um, there's a lot in the similarity video about how to do that, but this is really the easiest way to just divide up that bottom section. All right, next question. This is really a memorization fact. A parallelogram with congruent diagonals is a rectangle, and a parallelogram with perp diagonals is a rhombus. Every single year, 1, maybe 2 multiple choice, ask those exact properties. As long as you know that, bam, that's 2 easy questions to get right. All right, next one. What is the center and radius of a circle with equation x squared plus y squared minus 6x plus 12y plus 1 equals 0? So I'm going to fix that. So I'm going to need to complete the square to do this. So I'm going to group my x's together, leave a blank, group my y's together, leave a blank, and move the constant over to the other side. And then I'm literally going to complete a square. So I'm going to take half of this middle term, I'm going to square that, and I'm going to add that in here. And notice I just drew in a little completed square, right? Now whatever I do to one side, I also do to the other, so I add 9 there. I'm going to do the same with the y's. Half of this is 6. Square that, it is 6 squared, which is 36. Add that to one side, also add it to the other. And now I'm going to get this into standard form. So adding up on the right side, this would be 36 plus 8, which is 44. And then I need to factor this. And it always, always, always factors the same exact way. You're going to take this variable and that number, whatever half was, x minus 3 squared. Don't change any signs, just copy it exactly. We're going to take this variable and that number, and this is going to be plus y plus 6 squared. So this is standard form. Now, in this question, it said find the center and the radius. So the center here would be at 3, negative 6, and the radius would be the square root of 44. And let's say they said to put that in simplest radical form. So I know that that is 4 times 11. So that's the square root of 4 times the square root of 11, which equals 2 radical 11. So that's my radius and that's my center. Now, if they don't say simplest radical form, this is totally fine, okay? So if they don't say simplest radical form, just leave it. You don't need to simplify. All right. Now this is where I'm going to throw in a question that I didn't write originally. So I'm going to draw this picture, and I'm going to say this is 30 degrees, and this is a C, and I'm going to shade this, and I'm going to tell you my radius is 10. So part A, I'm going to ask for the area of the shaded sector. And there are two different ways you can do this. You can either think about a part over whole relationship. So we want to find area. So this is 30 degrees out of a total of 360 degrees. And I want to find what part of the area is, given that the total area is pi r squared. Cross multiply, solve that, and you will get your area. Now the other way you could do it is you could say, okay, well 30 over 360 is the fraction of the circle, and I'm going to find the fraction of the entire area. And these will give you the same answer either way, that way or that way, but make sure you know one of the ways. Now let's say I wanted to find the arc length. So for part B on this, I'm going to find the length of arc AC. So now what I'm talking about is the length of this piece, which is no longer a piece of the area, it's a piece of the circumference. So I'm going to say this is still 30 out of 360, but now I want to know the part out of the circumference, which is 2 pi r. Or you could say 30 over 360 is the fraction, and the whole circumference is 2 pi r, and get it that way. So again, either of these ways work perfectly, but make sure you know one of them. All right, next one, and there's a ton in my similarity video about this. So solve for x. So the big thing I look at here is, yes, 15 and x just look like parts of sides, but 7 and 11 are whole sides. So I'm actually going to redraw this into two triangles. The little triangle is 7 and 15. That's pretty easy to tell. The big triangle is 11, and then this side is x plus 15, because those are both together. So setting this up to solve it, I would get 11 over 7 equals x plus 15 over 15, because remember what I'm doing is corresponding part over corresponding part equals corresponding part over corresponding part. So this gives me 165 equals 7 times x plus 15. Distribute out your 7, and x should equal 8.4. All right, next one, and in my first live stream about describing rigid motions, you can see more about this one. Determine a series of rigid motions that maps ABC to PQR, which means this is the pre-image and this is the image, okay? And I'm just going to say 2 there because I don't really know if it's 3 or 4 or what. Then explain why they must be congruent. So the best way to do these would be to actually try out your rigid motions. So the first thing it looks like happens to me is it like flips over this. Right? I see there's some kind of flipping going on because it's not oriented the same way. So, okay, D is 3 away from this point. So I'm going to go 3 away over here, and I'll say that's D prime. C is 1 away, so I would say C prime would be here. And A is 4 away, so, nope, 5 away. So A prime would be there. So I would get this out as my image there. Okay. So now let's look at what happens. I want, based on this, A to map to P, B to map to Q, and C to map to R. So let's see if that happens. A could map to P by just moving down. B, that's a B, not a D, could map to Q just by moving down. And C could map to R just by moving down. So what it looks like happened there, given that those vectors are all the same length and they're all parallel, is a translation. So what I would say here is a reflection over the y-axis, and then a translation, and be very specific, down however many that was. I believe it was 6. 1, 2, 3, 4, 5, 6. So that answers the first part of this question. Now, I didn't need to say all the mapping things here because on this particular one, um, we have coordinates that we can give. Right? We can say y-axis. We can say down 6. So if it's off a coordinate plane, you need the mappings. If it's on a coordinate plane, you don't need them. But now let's answer, why does that mean these must be congruent? Well, a reflection and translation are rigid motions which preserve length and angle measure. Now you could always also say which form congruent figures or anything like that. But here's the big thing. Explain why these triangles. So you have to say here, talk about reflections and translations. You can't just spew the word rigid motion because we did a reflection and we did a translation. So this needs to refer back to kind of our problem here. What's the actual problem they asked me to address? And make sure you're referring back to that in your answer. All right, let's move on to some proofs. So, this proof, I want to show the triangles are congruent. I'm given that JM bisects angle J. So I know that angle J, this here, is going to be bisected, which means cut in half. So those two angles are going to have to be the same. And I know that JM is perpendicular to KL. Notice in my given I have no congruent statements, right? None. So I'm going to need to say all three here. So I know these angles are going to work. I know these angles will be perpendicular. And so I also see that I have some reflexive property there because JM is shared by both triangles. So seeing this, I have angle, side, angle. And so that is my plan. If you need more help with triangle proofs, I have one whole video of me doing them and then about 8 videos of very walked through triangle proofs. So feel free to go back and look at those. So let's do this one. I'm going to put my statement and my reason. Again, on the Regents, you will copy your whole given for the sake of time, and because I don't have much of a voice, I am going to not write it for now. So let's start with what we knew. We used that JM got or bisected angle J. So I'm going to say angle 1 must be congruent to angle 2 because I had an angle bisector. And notice I'm not just saying bisect, right? I'm saying what type? Implies two congruent angles. All right, next I'm going to go to the next part of my given, which was that JM, sorry, that those are perpendicular, which means angle 3 and angle 4 are right angles because perpendicular implies right angles. And if they are both right angles, now I can say that they are both congruent because right angles imply congruent angles. So that's an angle and an angle. So let's get that side. So I'm going to say JM is congruent to itself because of the reflexive property. Check. And once all three are checked off, then I can say that the triangles are congruent. Now, a common mistake here is people thinking, oh, all three are checked off. That means I can say my proof statement. That's only true if the thing you're proving is that the triangles are congruent, which in this case it is. But it won't always be. So make sure when all three are checked off, you know that just means the triangles are congruent. All right, let's look at another one. So I'm given this information about these triangles. I want to prove that CA is congruent to CB. So this is what I'm talking about, where your proof statement is not necessarily that the triangles are congruent. So my goal first is going to be that the triangles are congruent, and then the proof statement I will try to get after that. So let's start with what we know. I have perpendicular, so I'm going to say that's going to tell me that those two angles are right angles. I have that D is the midpoint of AB. That's going to give me that those sides are congruent. And I have a shared side again, so that's reflexive property. So my plan here is side, angle, side. So again, you are going to rewrite the whole given. I am not for right now because I am ill. Alright, so we're going to say angle 1 is congruent to angle 2. Or actually, we need to do something before that. Because we were given perpendicular, right? So I'm going to say angle 1 and angle 2 are right angles because perpendicular implies right angles. And then I'm going to say that that means angle 1 is congruent to angle 2 because right angles are congruent. So check off an angle. Now I need my sides. So CD is congruent to itself because of reflexive property. That's a side. And AD is congruent to BD because, look at your given, midpoint implies two congruent segs. Check that off. So now once all three are checked off, I can say that my triangles are congruent. So triangle ADC is congruent to triangle BDC by side angle side. And now that they're congruent, I can say, well, that means CA is congruent to CB because you can say one of two things. Triangles congruent implies corresponding segs congruent, or CPCTC. Again, if you're going to say this, it's got to be written perfectly and in that order. So I would err on the side of writing this where it could be in your own words a little. All right, next question. Let's do a little trig. As shown in the diagram below, the angle of elevation from a point on the ground to the top of the tree is 34. Okay? If the point is 20 feet from the base of the tree, well, there's the base, so that means this is 20. What is the height of the tree to the nearest tenth of a foot? So I'm going to start at the acute angle they gave me, which was 34. From that, I know that the hypotenuse is across from the right angle. The x is the opposite because it's across from the angle, and the 20 is the adjacent. If you need more help with this, go back to my right triangles live stream. But let's do this one. So I know here that I have the opposite and the adjacent. So that tells me to use tan because so, ka, toa. Toa is the one with opposite and adjacent. So tangent of the angle equals the opposite over the adjacent. I'm going to put that over 1 and cross multiply. X equals 20 tan 34. And then I'm just going to put that in my calculator. And that gives me 13.490170336848853. Notice rounding says nearest tenth, so this is 13.5 feet. For the next one, again, if this is something you need help with, go back to my Right Triangles live stream. We did a bunch of these, okay? So I want to know what is the length of BC. So I know I want that. And let's go back here. ABC is a right angle. AC is 12. AD is 8. I'm just going to fill this in there because I can figure it out and that's easy. And out to BD is drawn. So what we have here are three right triangles. We've got this little one, this medium one, and then the whole big one. And those are all similar triangles. So we're going to use a proportion to solve this. Now, you can either redraw these and use corresponding parts, or you can do some color coding, and we practice this more in that other live stream. So BC is a leg. That is over here on its own. I'm going to do that one color. And then the other two pieces I'm going to highlight are the piece closest to BC and this whole length. And so when I do that, I get my proportion. The one that is its own color is going to repeat. It's the geometric mean, one on the bottom, one on the top. And the other two will go in this other place. So here I get x squared equals 48. Square root both sides, so x equals radical 48. Now it does not ask you to simplify that, so you could leave it like this. But let's say they did. Well, I would say that that is the square root of 16 times 3. Square root of 16 times square root of 3, which is 4 radical 3. But again, if they don't ask you to simplify, don't do it. All right, let's do a couple more. I think we only have three. Yep. Okay, so next one is volume. A storage tank is in the shape of a cylinder with a hemisphere on the top. The highest point is 13 meters off the ground, and the diameter inside the cylinder is 8 meters. State the volume inside the storage tank. So I'm going to kind of break this up into two pieces. The first, I'm going to do the hemisphere. And I see here that my diameter is 8 on the bottom, so that means my radius is 4. So for the hemisphere, volume is half of 4/3, that should be a 4, pi r cubed. And then for the cylinder, volume is pi r squared h. And the difficulty for a lot of people comes in figuring out what h is here. So, figuring out h, I'm going to say, well, you know what? This is 4, so is that. Which means that the height of the hemisphere is 4. So, if this whole length is 13, that has to be 9. So the height of the cylinder is just 9. So these volumes are going to be, and I'm going to leave them in terms of pi for right now. 4 squared is 16 times 9, which is 144 pi. So that's the cylinder. And the sphere, this is 128 over 3 pi. So to find the total volume, I'm going to add those 128 over 3 pi plus 144 pi. Put those all into your calculator, and that will give you your total volume, which should be 586 meters cubed to the nearest cubic meter. So that's the nearest whole meter. Now, if the material stored has a mass of 2,500 grams, what is the density of the material? So let's think about this. Density is a mass over volume. They gave me the mass, and I just calculated the volume. So mass is 2,500. The volume is 586. And so this would be 4.2662116. And I'm going to say that maybe the directions I'd round to the nearest hundredth. So 27. And let's think about our units. The units of mass were grams. The units of volume were meters cubed. So it's that many grams per meter cubed. All right, 2 left. Line L is mapped onto line M by dilation centered at the origin with a scale factor of 3. Go back to my similarity live stream if you want more on that. The equation of L is this. What is an equation for M? So first I'm going to solve this for Y. So 4x minus 4 equals 2y. Divide everything by 2. So y equals 2x minus 2. Now, the important thing when you dilate a line is that dilated lines stay parallel. So this is still going to be 2x because the slope won't change. But the y-intercept will change because the center here is not on our line. So I'm going to dilate that by a scale factor of 3, and so this would be minus 6. Again, go back to my similarity live stream if that's something you need to think about. All right, last question. Part A, PB is 4, BC is 20. What is the length of PA? So the big thing you need to remember here is whole times outside equals whole times outside. Go back to my circles review if you feel like you need more practice on this. So this whole length is 24. The outside part is just 4. This whole length is x. And the outside part is just x. So here I get x squared equals 96. Square root both sides. Again, it does not say that you need to simplify your radical, so if it doesn't say, you can just leave it like that. All right, last one. I'm going to erase these markings so I have a little bit more space. Arc AC is 150, and arc BC is 150. What is the measure of angle P? Okay, so first let's figure out the missing arc. These two arcs together are 300, which makes this arc right here 60. Now to find an exterior angle, or really any angle, I'm going to shade to find the intercepted arcs. And I have 2 intercepted arcs here, and I'm going to go over those. So I've got AB, and I've got AC. Now, since these meet outside the circle, I'm going to subtract them. So I'm going to do 1/2 of AC minus AB, which is half of 90, which is 45 degrees. All right, so those are my top 12, 13 questions for the Regents. If you have questions, go back to any of my other live streams. These are all covered, but you guys got this, and I will see you at the Regents. Have a good day.